welcome to True Projects. In this video, we are going to explain the project title, which is Review of Artificial Intelligence Techniques in Chronic Obstructive Lung Disease. This project addresses the serious healthcare challenge posed by chronic obstructive pulmonary disease, which is COPD. COPD diagnosis, prognosis, patient categorization, and therapy need accurate and tailored techniques. Traditional approaches frequently struggle to deal with the enormous complexity of COPD data. This project investigates the use of cutting-edge AI approaches to address this problem of COPD diagnosis. Chronic obstructive lung disease is a major public health hazard that needs precise and prompt identification in order to be effectively treated. To assess patient data, this project investigates several machine learning models, including ensembling approaches such as the voting classifier and sophisticated techniques such as CNN and CNN with LSTM, by utilizing the capabilities of artificial intelligence. The project's goal is to use a wide range of machine learning techniques such as random forest, decision tree, naive Bayes, Adabus classifier, logistic regression, MLP-ANN, support vector machine, KNN, voting classifier, extra tree, Bayes network, CNN and CNN with LSTM. Each algorithm serves as a distinct goal, ranging from enhancing prediction accuracy via ensemble approaches such as voting classifier to in-depth feature analysis via sophisticated techniques such as CNN and CNN with LSTM. This project objective is to construct a complete COPD diagnosis tool that caters to the multidimensional characters of the respiratory ailment, thereby improving healthcare outcomes by merging these various AI approaches. Coming to requirements, we need hardware and software requirements. In hardware, operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. In software, we need Anaconda 3 and Visual Studio Community version. In the flow of project, we designed these modules to execute the project. The first module is importing packages. This module involves importing necessary Python libraries and frameworks like NumPy, Pandas, Scikit-learn, TensorFlow, Flask, and Node to facilitate data manipulation, machine learning, and web development. Second one is exploring the dataset, arrhythmia data. In this module, the project begins by acquiring and exploring the arrhythmia data, which contains vital patient information related to COPD. Understanding the dataset is crucial for feature selection and model building. Third one is data processing. Data pre-processing includes tasks like handling missing values, feature scaling, encoding categorical variables, and preparing the data for machine learning algorithms. Clean and well-structured data is essential for accurate model training. Fourth one is visualization using Seaborn and Matplotlib. Data visualization helps in gaining insights from the dataset. Seaborn and Matplotlib are used to create informative plots and graphs, aiding in data exploration and feature selection. Fifth one is splitting the data into train and test. The dataset is divided into train and testing subsets to evaluate model performance effectively. This ensures that model's generalization capability is assessed on unseen data. Sixth one is model building. Multiple machine learning models and deep learning algorithms are applied to predict COPD outcomes. These algorithms include random forest. It is an ensembling method that combines multiple decision trees to improve classification accuracy. Random forest is employed for its robustness and ability to handle complex relationships in COPD data, reducing overfitting. Next one is decision tree. It is a tree-based algorithm that makes decisions by splitting data into branches based on features. Decision trees are interpretable and helps in understanding feature importance in COPD diagnosis. Third one is naive Bayes. It is a probabilistic algorithm based on Bayes' theorem that assumes feature independence. Naive Bayes is used for its simplicity and effectiveness in probabilistic classification tasks related to COPD. Fourth one is Adabus classifier. It is an ensemble method that combines multiple weak classifiers to create a strong one. Adabus is applied to improve model accuracy by focusing on previously misclassified data points in COPD diagnosis. Logistic regression. It is a linear algorithm that is used for binary classification. Logistic regression is used for its simplicity and effectiveness in modeling the probability of COPD occurrence. Sixth one is MLP-ANN, which is multi-layer perceptron artificial neural network. It is a deep learning model that is composed of multiple layers of interconnected artificial neurons. MLP-ANN is used to capture complex patterns and relationships with the COPD data due to its deep architecture. Next one is support vector machine. It is a powerful classifier that finds a hyperplane to separate data into distinct classes. SVM is employed for its versatility in handling the linear and non-linear data in COPD diagnosis. Next one is K-nearest neighbor, which is KNN. It is an instance-based classification algorithm that assigns labels based on nearby data points. KNN is used for its simplicity and effectiveness in COPD classification tasks, especially in scenarios with the spatial dependencies. Next one is voting classifier. It is an ensemble method that combines predictions from multiple classifiers to improve overall accuracy. Voting classifier leverages diverse algorithms to enhance COPD diagnosis accuracy by aggregating their outputs. Next one is extra tree. It is a variant of random forest that introduces additional randomness in tree building. Extra tree is applied to improve model generalization by further diversifying the individual decision trees. Next one is Bayes network. It is a probabilistic graphical model that represents dependencies between variables. Bayes network is used to capture complex relationships and dependencies within COPD related features. Next one is CNN, which is convolutional neural networks. It is a deep learning architecture designed for image-based data, feature convolutional layers. CNN is used for its ability to automatically extract relevant features from medical imaging data associated with COPD. 13th one is CNN with LSTM. It is a hybrid model that combines convolutional neural networks and long short-term memory networks for sequential data. CNN with LSTM is applied to capture both spatial and temporal dependencies in COPD data, enhancing prediction accuracy in time series scenarios. Next module is training the model. Each algorithm is trained on the training dataset to learn patterns and relationships within the data. Next module is building the model with the voting classifier. The voting classifier module combines the predictions of multiple models, example, random forest, decision trees, SVM, etc. to enhance overall prediction accuracy. It leverages the strength of various algorithms for improved performance. The 9th module is Flask framework with SQLite for sign-up and sign-in. A web application is built using the Flask framework and SQLite database to facilitate user registration and authentication. This enables users to input their feature values and access the model's predictions securely. 10th one is user input and pre-processing. Users provide feature values related to COPD, which are pre-processed to ensure compatibility with the trained model's requirements. 11th one is prediction. The trained model is utilized to predict COPD outcomes based on the user's input. 12th one is final outcome displayed through frontend. The prediction results are displayed through a user-friendly web interface, allowing users to access and interpret the model's findings. These are the modules and algorithms collectively from a comprehensive system of COPD diagnosis and management. This is a comparison graph after training and building the algorithms, which are represented on y-axis, and they got the accuracy scores. Here on x-axis we have the accuracy score, and on y-axis we have the algorithms. And here is the algorithm's accuracy scores, and this is the comparison graph of accuracy. For execution, first we need to open code folder which contains source codes. This is the code folder of the project, and this is the archive folder. This folder contains the dataset which is used in the project. And this is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. And this is the template folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the notebook.ipynb file. An ipynb file is a Jupyter notebook file which contains a combination of code graphs and outputs all in one place. It allows user to write and execute code in individual cells, making it popular choice. Next one is app.py file. This .py file likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And this is the sign-up file. This file is the database file that is used to store the user information. And front end is built using the Flask framework. Now we need to copy this path and paste it in Anaconda prompt. Here we need to use the cd command followed by space and then paste the copied path. Now I need to click on the enter. So here the path is changed. Now I need to type python space app.py and click on enter. Here this will compile app.py file using command which is python app.py in the Anaconda prompt. This command will execute the Python script and perform a runtime check for any syntax or logical issues. Here, after running the app.py file, the Flask framework will host the application locally at the default address which is this one and the port number which is this one. Now we will copy this link and paste it in any browser. I prefer the Google Chrome. Here I need to paste the link and click on enter. Here it has redirected to the home page which is displayed in the browser. Now I need to click on the button sign up. We need to fill all the registration details if we are registering newly. Now I will click on the button sign in because I have already registered. I'll give the username and the password. Now I'll click on the button sign up. Sorry, I need to click on again sign up. Now I'll click on the button submit. So here it has redirected to this page. Now we need to fill all the details of the patient and then click on submit. So step by step we will fill all the details. So here I will enter the age of the patient and here packet history and here MWT1 and here MWT2 and here NWT1 best which is distance that patient walks in 6 minutes and here I need to give the FEV1 which is measure of lung function and here FEV1 PRED. And here I need to give the total volume of air that a patient can forcibly exhale in one breath. And here I need to give the FVC PRED. And here I need to give the CAT value. Here HAD value. And here quality of life index. And here age quartiles. And here COPD. Of which stage he is. And here I need to give the gender, so I will select female. And here I need to select smoking, which means the person has smoking habit or not. So she has smoking habit. And now we'll select the diabetes. She has no diabetes, no muscular pain, no hypertension, arterial fiber as yes, and IHG as no, and click on submit. So here the diagnosis is predicted as mild CCOPD. Similar way we will predict with all the cases. Now I will enter all the details. Here I entered the details of other person. Now I'll click on the button submit. So here the diagnosis is predicted as moderate CCOPD. Now we will try with the other case. Again I need to fill the details of other patient. So here I will be entering the age. Here I will enter the packet history. Accordingly I will enter all the details. Now I'll click on the button Submit. So here diagnosis is predicted as severe CCOPD. In other way, we will try with the other case. Now here I need to fill all the details again of the different patient. Here I will enter the age, packet history, MWT1, MWT2, and the FEV1 score and the FEV1 spread, volume of the air that patient can forcibly exhale, and here the CAT value, and here the HAD value, and here quality of life index, and here age quartile and COPD. I will select the gender as male, and I'll select the smoking habit as no diabetes, no muscular pain. He has the hypertension, arterial fiber is yes, and this is no. Now I'll click on the button Submit. So here diagnosis is predicted as a very severe CCOPD. Now we will sign out. In this way, we can record all the details and then get the patient details, which means he has a disease or not. The project emphasizes the critical role of artificial intelligence in developing the area of COPD diagnosis. Following a thorough examination of various machine learning algorithms such as extra tree, voting classifier, support vector machine, random forest, decision tree, naive Bayes, and Adabos classifier, it is clear that AI-driven solutions offer a transformative approach to addressing the challenges posed by COPD. These AI algorithms not only have great accuracy, but they also have the potential to dramatically improve healthcare outcomes through early diagnosis. This project demonstrates the capability of AI by combining several algorithms. This initiative emphasizes the importance of AI in offering precise and effective solutions for COPD diagnosis, resulting in better patient care and results.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.